Alright, let's proceed with partial fractions. Now, when you've been given in high school, there are questions which would come like they've given you 1 over x minus 1 plus, let's say, 2 over, let's say, x plus 2. They say merge as a single fraction. So to merge this as a single fraction, get what's on top here, you multiply with what's down there. That is going to give you x plus 2. Then guess what's on top here, multiply with what's down. That is going to give you 2x minus 2. And then multiply the two denominators to be x minus 1, x plus 2. And this gives you add like terms on top. This is a positive 2, this is a negative 2. They'll cancel out x plus x, 2x, that would be 3x. And then down you have got x minus 1, x plus 2. So here we have merged as a single fraction. Now when you want to go back from the single fraction to these two fractions, that is what we call as decomposing into partial fractions. So we can actually work on just this thing that we have. Now there are different types of partial fractions, and it depends with the type of partial fraction that you're talking about, the rule that is going to apply. So starting with this kind of partial fractions, now you look at the degree or the highest power on top. Let me ask, what is the highest power on top here of x? Okay, what of the denominator, what is the highest power of x?
Two.
Okay, the denominator has got the highest power of 2. So you multiply this x and this x, that will give you x squared. So the highest power of x in the denominator is 2. So this one we call it as a proper fraction, alright? So when you've got a proper fraction, you want to express into partial fractions. So we're going to get this 3x divided by x minus 1, x plus 2. Every time you have got a proper fraction, just write those two denominators. As long as the denominators you can see, they are linear. Please take note, they are linear. So you write that x minus 1 plus, you have got x plus 2. So since this one is linear, on top you're supposed to have a constant, so I'm going to put a. Even this one is linear, on top you're supposed to have a constant, so I'm going to put b. Now what I mean by linear is that they are not squared functions, they don't have a power, alright? So my aim is to find the value of a and the value of b. Then I've decomposed into partial fractions. So this one, this will give you 3x over x minus 1, x plus 2. Merge this as a single fraction over the other side. So multiply this with what is down here. Okay. So that is going to give us a, open brackets, x plus 2. Then multiply what is on top with what is down, plus b, x minus 1. And then multiply the two denominators. That is going to be x minus 1, x plus 2. Florence, are we together?
Yes.
Okay, so since the denominators are the same on both ends, we'll just equate the numerator. So 3x is going to be equated to a, open brackets, x plus 2 plus b, open brackets, x minus 1. Now for something that is in this form, when these factors are linear, it is more easier to say, how can I make this part a 0? What do you think? What number can I remove or add to for me to have a 0?
-2.
Negative 2. So I'm going to say let x be equal to negative 2. So in this equation where there is x, I'm going to put negative 2. So 3 times negative 2, that will give us negative 6. And that will be equal to, already we know that negative 2 plus 2 here will give us 0. And 0 times a will still be 0. So this part will be 0. I'll not even write it. And then we'll go the other side. Negative 2 minus 1 is negative 3. And then times b, that will be negative 3b. So meaning that b is going to be equal to 2 if we divide both sides by a negative 3. And then for me to make this a 0, I'm going to make x to be 1. So say let x be equal to 1. So 3 times 1 is going to be 3. That will be equal to, we put also 1 here. 1 plus 2 is 3 times a, that will be 3a. Because this part it will give us a 0. So that will give us a being equal to 1. Meaning that this is going to be 1 on top, and then on top you are going to have 2. We can see that is what we had at the beginning, right? So we have decomposed into partial fractions. As simple as that. So basically, for something that is a proper fraction, it is very easy to break into partial fractions. Do you have any questions before we proceed? Any question?
So on the denominators there, they haven't cancelled, but at the end here, you have removed them.
Oh, I divided both sides. So divide here by 3, also here divide by 3. Is that okay now?
Even on the third part, here where it's 3x divided by these two denominators.
Oh, so that's where I mentioned to say the denominators in both are the same. Since the denominators are the same, it means that also the numerators are supposed to be the same. So just equate the numerators since the denominators are the same.
Okay.
Yes. So this is how we work with those partial fractions where they are proper, right? We can as well look at another example. Let's say I've got 2 divided by x squared. You can actually also be given a cubic function in the denominator. I hope we know how to factorize cubic functions. Okay, you can be given a cubic function, so you should be able to know how do you factorize cubic function. Let me try to see if I can. Okay, you can also be given like a cubic. I don't know, for me to make one it will be hard. So let's say this is what you've been given. They ask you to break into partial fractions. So also you can see that the denominator has got power 3, because if you multiply this and this, the highest power in the denominator is going to be power 3, but on top we have got a constant. So it is also a proper fraction. So I'm going to say, write the first denominator, which is x plus 1, the next one, which is x minus 2, the next one, which is x minus 1. So on top, since you have got linear factors, just put a, b, and c, like that. So this is going to give us 2 over x plus 1, x minus 2, x minus 1. Now merge this side also as a single fraction. So we're going to write the 3 denominators, x plus 1, x minus 2, then x minus 1. So this denominator in 2 here, so this one is going to cancel. So these two are going to remain. These two which remains, you multiply with the a, so you are going to have a multiplied by x minus 2, x minus 1. Then this one also into the denominator, this denominator will cancel. What remains you multiply by the b, so we're going to have b multiplied by x plus 1, x minus 1. And then the x minus 1 goes into x minus 1, it will cancel, so these two are going to remain. Those two which remains you multiply by this, so we're going to have c x plus 1, x minus 2, like that. Same here, since the denominators are the same, equate the numerators, alright? So we're going to equate the numerators. So we're going to have 2 being equal to a x minus 1, that is actually x minus 2, x minus 1, plus b x plus 1, x minus 1, then plus c we have x plus 1, x minus 2. Is this okay? Is this okay?
Yes.
So you can think of how can I eliminate a? How can I eliminate a? Those are some ways you can think about. Okay, we can say let x be equal to a positive 2, right? Let x be equal to a positive 2. So meaning that 2 is going to be equal to, if you put 2 here, 2 minus 2 is going to be 0. So meaning that this portion is going to be 0. Even here, we're going to have 2 minus 2, that will be equal to 0. So meaning that even this portion is going to be 0. So the only thing that is going to remain is a b. So put 2 here, 2 plus 1 is a 3. Put 2 here, 2 minus 1 is a 1. So 3 times 1 is a 3. And then times b, that is going to be what? A 3b. Okay? Meaning that b is going to be equal to 2 over 3. And then I can also eliminate, let's say b. So I'm going to say let's say let x be equal to positive 1. And then we replace here positive 1, meaning that a is going to be eliminated. We put here positive 1. B is also going to be eliminated. So we're just going to remain with the portion for c. So we're going to have also 2 being equal to, put 1 here. Okay, so that is x plus 1, which is, of course, x is 1. 1 plus 1 is 1. And then you also put here 1 minus 2 is negative 1. So that is 2 times negative 1, which is then negative 2. And then times c. So mean that c is going to be equal to negative 1. You can also let x to be equal to, what can we let it for us to cancel out c? Let x to be equal to a negative 1. Such that if I put negative 1 here, negative 1 plus 1 to be 0. I also put negative 1 here, negative 1 plus 1 to be 0. So b and c will cancel out, so remain with this portion for a. So put negative 1, negative 1 minus 2 is negative 3. Negative 1 again minus 1, that is going to be negative 2. So I've got negative 3 times negative 2, which is a negative 6, right? So I'm going to have, positive 6. 2 is equal to 6a. Then divide both sides by 6. So a is going to be equal to 1 over 3. Is this okay? Florence, is that okay?
Yes.
Okay, so meaning that where there is a, we're going to put 1 over 3 divided by x plus 1. Where there is b, we're going to put the 2 over 3 divided by x minus 2. Where there is c, we're going to put negative 1 divided by x minus 1. Now, since we have got fractions on top, those denominators of the fractions on top will come in the denominator. So this will be 1 over 3 multiplied by x plus 1, and then plus 2 over 3 multiplied by x minus 2, then minus 1 over x minus 1. So we have decomposed into partial fractions. I hope that is okay, is it? So this is how you get to break into partial fractions for those fractions which have got the denominator which is having a higher power than the numerator. So let's say you want to break into partial fractions, 2 divided by x squared minus 4. So in a case like this one, you should be able first to factorize the denominator. Even if they've given you, let's say, 2 divided by x squared minus x minus 6. Factorize the denominator. We know how to factorize quadratic expressions. So factorize the denominator. So if I factorize the denominator, this is going to be the same as 2 divided by x minus 2, x plus 2. Like this is a difference of 2 squares. So that is going to be it, factorized. Meaning that I can express this one in the form a over x minus 2 plus b over x plus 2. We can now decompose into partial fractions. So we're going to have 2 over x minus 2 x plus 2. This being equal to, get what is on top, the a will multiply with what is down b. That will be a x plus 2, and then plus b will multiply with what is down a, x minus 2. Then we multiply the two denominators, x minus 2 x plus 2. So what are we going to have? The denominators are the same, so equate the numerators. We're going to have a x plus 2 plus b x minus 2. So for me to eliminate a, what should be the value of x? I'll let x to be equal to what? How can I eliminate a? What should be the value of x? Florence, what do you think?
Negative 2.
Okay, so let x to be equal to negative 2. So mean that 2 is going to be equal to, this will be eliminated. We are going to have negative 2 minus 2 times b, that will be negative 4b. Meaning that b is going to be negative 1 over 2. Then to eliminate b, we are going to let x be equal to positive 2. So we're going to have 2 being equal to 2 times 2 plus 2 times a, that will be 4a. That a is going to be positive 1 over 2. So now go back. At the end, we'll now say therefore, this one broken into partial fractions is going to be, where there's a, we put 1 over 2 divided by x minus 2. And then where there's b, we found negative 1 over 2 divided by x plus 2. Which we can bring the 2's in the denominators, 1 over 2 x minus 2, then minus 1 over 2 x plus 2. So this is partial fractions involving uh, proper fractions. Now at times the denominator can be a repeated linear factor. Repeated linear factor. How do you know that it is repeated? You are going to see it in brackets squared. So let's say you want to break down 2 divided by x minus 1 squared. This is called a repeated linear factor. Now this comes from something like this. When you have got 1 over x plus 2 over x squared plus 3 over x to the power 3. When you want to make this as a single fraction, x to the power 3 is common. Oh, sorry, just a moment. Alright, so I'm saying when you want to work out a partial fraction for repeated linear factor, like 2 over x minus 1 with a square, you can think of something like this which I've written. I've got x 1 over x plus 2 over x squared plus 3 over x to the power 3. When you want to measure as a single fraction, you look at the common denominator, that is x power 3, right? And then you'll be saying x into x power 3. So this is the common denominator. So this is how we also consider repeated linear factors. So this one where there is a square, to break it, you are going to say this is going to be, first you write x minus 1 in increasing order plus, you now write x minus 1 to the power 2. So you don't say x minus 1 alone and then plus again x minus 1, since you know that x minus 1 squared means x minus 1 multiplied by x minus 1. No, you don't write that. This is repeated, so you write it in this form. So since this is linear, on top you are going to have a, here you are going to also have b, because what is inside here is linear. I hope that is okay. So this will give us 2 over x minus 1 squared, and that is going to be equal to, I'll get this, I'll multiply with what is down b. It is going to be a x minus 1 squared, and then b multiply with what is down a, that is x minus 1. Okay, supposed to multiply two denominators. Now the way I've done this is going to be a bit of complex. So since x minus 1 and x minus 1 squared can go into x minus 1 squared, I'll write that x minus 1 squared. X minus 1 into x minus 1 squared, we're going to remain with 1x minus 1. We multiply that by a, so we're going to have a x minus 1. Then x minus 1 squared into x minus 1 squared will be 1. 1 times b, that will just give us a b. Since the denominators are the same, equate the numerator. So we're going to have 2 being equal to a times x, that will be ax, a times 1, that will be a, negative a, and then plus b. Now the a and the b, these are constants. I'll pair them together. So we're going to have 2 is equal to b minus a. I'll pair it together. And then plus a has got an x. I'll also pair it alone. So the b minus a, which is a constant, should be equal to a constant this side, and that side we have got a constant 2. And then the a with an x should be, so the number in front of x should be equal to the number in front of x this side. Since we don't see any x, it means that the number in front of x is a 0, meaning that a is going to be equal to 0. This tells us that b is going to be equal to what? It's going to be equal to 2. So breaking this into partial fractions, it means that the final answer is going to be 0 over x minus 1 plus 2 over x minus 1 squared. So we've broken into partial fractions. So basically what we're able to see is the answer is just this, right? Because 0 over anything, the answer is 0. So just write that. Are we okay? Are we good? Hello? Friends, are we together?
Yes, sir.
So this is how you work with repeated linear factors. So just say this, if this was power 3, you would have just added c and then put x minus 1 power 3, and then you continue like that, so nothing changes. Now at some times you are going to have an irreducible quadratic factor. So you can't reduce the quadratic factor. What do you do in that case? So let's say you have got x plus 1 divided by x minus 2, and then you have got x squared, let's say x squared minus 2. So this is the partial fraction that you want to decompose. Now this quadratic factor, you can't reduce it further than this. Like you can't factorize it, right? You can't factorize it. So what do you do in that case? Or I could have put a plus 4. X squared plus 4 can't be factorized. It is different from x squared minus 4. You can factorize this as a difference of two squares. X squared plus 4 is irreducible. So how can you work out this one where it is irreducible? So what you are going to do, this one you write it, you write the two denominators. You have got x minus 2 plus the other denominator I've got is x squared minus 2. Now since this one is linear, meaning that what is supposed to be on top is a. Now since this one is quadratic, when the denominator is quadratic, what should be on top should be linear. If the denominator is linear, what should be on top should be a constant. So on top we are supposed to have a linear factor. So this is already a. So on top I'm going to put b x plus c. This is linear because down we have got quadratic. Alright. Are we good? Are we good? Alright. And then from there, I'm going to make this as a single fraction. Multiply a with what is down the bx plus c. So I'm going to have a open brackets x squared minus 2. Then multiply what is on top of the second fraction, which is the bx plus c, with what is down the face, which is the x minus 2. And then over, multiply the two denominators, that is x minus 2, x squared minus 2. Since the denominators are the same, then the numerators are supposed to be the same. That will be x plus 1, that will be equal to, I'm going to distribute the a, okay, so that will be a x squared minus 2a, and then I'll multiply also the bx with the x, that will be bx squared, bx times negative 2, that will be negative 2bx, and then c times x, that will be cx, then c times negative 2, that will be negative 2c. And then I'm going to pair up, that will be x plus 1 is equal to, I'll pair up those with a square, we have got this one and this one. I'm going to get b, I'm going to get the a and the b, so I'm putting them in brackets a plus b, and then I write the x squared at the end. And then I'm going to get those with only x. We have got this and this. So I'm going to get, I'll put a plus. I'll write c, that's the number in front of x, and then I've got a negative 2b, it's a number in front of x, and then I'll put x outside. And then I'm going to get those without x. We have got a negative 2a, we have got a negative 2c. So I'll put a plus, and then put them together, negative 2a minus 2c. Okay, we are going to be comparing this, but even before I can compare, I could have found at least the value for a. I can find that, it's easy. You can see this. How can I make this term a 0? Anyone to answer us?
X should be positive.
Okay, x should be positive 2, so this is going to be 0, and the whole of this term is going to turn into a 0. And then I'll put also 2 here, 2 plus 1, that will give us a 3, and that will be equal to, I'll put a 2 here. 2 squared is 4 minus 2 is 2. 2 times a is 2a. Mean that already a is going to be 3 over 2. We can actually find a easily. A is 3 over 2. In case you didn't know that. So start equating terms. So do we have anything with x squared here? We are equating coefficients. So the number in front of x squared, that is the a plus b, should be equated to 0 the other side, because we don't have any x squared, meaning that a is equal to negative b. And then the number in front of x, which is the c minus b, actually minus 2b, should be equal to, what? Anyone? C minus 2b is going to be equal to what? So you can see c minus 2b is in front of x. Okay? So you go to the other side of the equation, you find what is in front of x. So what is in front of x? This is the x. What is in front?
One.
It's a 1. So mean that c minus 2b is going to be equal to a 1. And then you can go to the constant, which is negative 2a minus 2c. The constant is going to be equal to what? What is the constant the other side of the equation? Florence, what's the constant the other side? Hello, are we moving together?
One.
It is a 1. Paxina, are you following? Or maybe people are pretending to be in class, they've left their
No,
phone.
no,
Yes.
I'm behind. I'm behind on well now we are finding the coefficients.
So you don't have x squared this side, right? So mean that the coefficient of x squared is 0. 0x squared plus x plus 1. So this number in front of x squared should be equal to this number in front of x squared, which is a 0. That's the one we have found here. And then you go to the coefficient of x, the number in front of x, that is c minus 2b, should be equal to the number in front of x here, which is a 1. And then this constant, which doesn't have any x, should be equal to this constant, which doesn't have any x. Is that okay?
Yes,
Okay. We should now find the values. So I think I even did it much easier the other time. So I can go on uh, where there is b here. I'm going to substitute. We know that b is equal to negative a, or a is equal to negative b. So we are going to have c minus 2. Where there is b, we are going to put negative a, and that will be equal to 1, meaning that c plus 2a is going to be equal to 1. I can make c the subject, the formula c is going to be equal to 1 minus 2a. And then I'll come in this equation where there is c, I'm going to put that. So I'm going to have negative 2a minus 2. Where there is c, I'm going to put 1 minus 2a. That will be equal to 1. So I'm going to have negative 2a minus 2 plus 4a. That is going to be equal to 1. So add like terms, 4a minus 2a, that is going to give us 2a. Take negative 2 the other side, becomes positive 2, it finds a 1. 1 plus 2 is a 3. Mean that a is going to be 3 over 2. We have found a, so we can find actually b. We know that a is simply negative b, or b is negative a, meaning that b is equal to negative 3 over 2. Then we can find c. C is going to be 1 minus 2. Where there is a, we put 3 over 2. So that will be 1 minus this 2, and this 2 can cancel, minus the 3. So meaning that c is going to be negative 2. So such easy, and so we'll just get to substitute. We have found a as 3 over 2 divided by x minus 2, and then plus, we have found b as negative 3 over 2x. We have found c as negative 2 over x squared minus 2. So I can just express this well. C is going to give us 3. Yeah, sorry that it isn't showing. Did we get how I found the values of a, b, and c? Hello, did we get how I found those values?
yes, we are using.
Okay. So we're going to have 3 over 2. So we're going to have 2x minus 2. Now you can see this is a negative, this is also a negative, right? I can factorize out that negative. So I'm going to put it here. Okay, I'll factorize out the negative. That means now we're going to have 3 over 2x. Okay, and then you're supposed to have, now this is going to be a bit of trick. If I factorize out the negative, let me first keep it as a 3, and then we're going to have a negative 3 over 2x. I also want this one to be a fraction, to be a fraction. So how can I write 2 with a 2 in the denominator as a fraction? How can I write 2? So 2 is the same as what number over 2? That's the question. What do you think? Florence, what should be the value of x here? You people, are we lost or something?
What's the question?
What should be the value of x? We want to express 2 to have a denominator of 2. What number divided by 2 is going to give us 2? So this is 4 over 2. Then divided by x squared minus 2. So the aim is I don't want to have a fraction like that. So therefore this is going to give us 3 over 2 x minus 2 and then plus. So we are now going to remain with negative 3x minus 4 and then the 2 now go in the denominator. Then we are going to have x squared minus 2. Is this clear with us? Are we good with it?
Good.
Okay. So this is how you basically deal with partial fractions with irreducible quadratic factor. Now the last type of partial fraction that you should understand is an improper fraction or an improper partial fraction. An improper partial fraction, you are going to have on top, if you have got x squared, even down you are going to have the highest power as x squared, or on top you have got the highest power as x to the power 3, down you have got x power 2. Just a moment, I get to work with the network. Are you able to see the board? Just the network did something. Can you see? Are you able to see my board?
Yes.
Okay, the last type of partial fraction I was talking about is an improper partial fraction. Now, when you talk about improper, the highest power on top is going to be the same as the highest power down, or the highest power on top is going to be bigger than the highest power down. This is an improper fraction. And so the way you get to break it into partial fractions is going to be a bit of different, all right? It's going to be a bit of different. So, how do you work them out? Let's say you have got x squared uh, minus 2x plus 3, and you are dividing that by x squared minus x minus 6. You want to break this into partial fractions. Now the first thing that you need to do is that you need to divide this into what is on top. You find the quotient and the remainder. You know, when you get to divide, like if I say 4 over 3, the answer is going to be 1. Okay, remainder, let me not use the 3, let me say 5 over 2. The answer is going to be 2, remainder 1 over 2. So this is how you express this thing here. You are finding is the quotient, here is the remainder, and then here is the divisor. So this is how we want to express when you have got an improper fraction, you want to express it in this form, right? That's the form you want to express it. But how do you find it? We are going to use long division. Going to use long division. So what we are dividing into is supposed to be inside the x squared minus 2x plus 3. What we are dividing with is x squared minus x minus 6. Now what you do is you just use the highest power. You just get this, the highest power. That's all you'll be using. So it's the x squared into x squared. That is going to give us a 1. Alright? And then 1 multiplied by everything here to give us x squared minus x minus 6. And then you subtract. X squared minus x squared is 0. Negative 2x minus negative x, that will be negative x, right? And then 3 minus negative 6, that is going to be a positive 9. Meaning that if you take x squared minus x minus 6 into what is on top, the answer is going to be 1, and then plus the remainder we are remaining with is negative x plus 9, and then over the divisor is x squared minus x minus 6. Are we okay? Are we okay?
Yes.
And so we need now to factorize this denominator. If we factorize, the product is negative 6, the sum is negative 1. What two numbers can we multiply to get negative 6? If we add them, we get negative 1. What two numbers do you know? So that is a positive 2 and a negative 3. So this is going to be x plus 2, x minus 3. So that is how we are going to write it. So meaning that I can write this. So when we reach at this point, now you just get this. This is the one you break into partial fractions, just this end. Okay. So the negative x plus 9 divided by x plus 2, x minus 3. This is going to be equal to a over x plus 2 plus b over x minus 3. And this will give us negative x plus 9 being equal to a x minus 3 plus b x plus 2. Since the denominators are the same, I'll just write the numerators. Are we okay up to here? Are we okay?
Yes.
So we are going to let x be equal to 3 for us to eliminate a. So we are going to have negative 3 plus 9, which will be a 6. And then we'll come here. 3 plus 2 is 5 times b, that will be 5b. Meaning that b is going to be 6 over 5. And then we are going to let x to be equal to negative 2 for us to eliminate b. So negative 2 times that negative to give us positive 2 plus 9 is 11. That will be 11, and that will be equal to negative 2 minus 5 is negative 5 times b, that will be negative 5a. Then that a is going to be equal to negative 11 over 5. So if it's to break this into partial fractions, meaning that, of course, meaning that we can break this into partial fractions, and basically what we are going to have is 1 plus, where there is a, right? Since a is representing, this part is representing just the O of that other one. So where there is a, we'll put now negative 11 over 5. Now divide that by x plus 2. Then plus, where there is b, we put 6 over 5. Now divide that by x minus 3. Just write that one now nicely to conclude. We'll say, therefore, x squared minus 2x plus 3 over x squared minus x minus 6 is going to be equal to 1. Okay, this negative and this negative, they'll give us a positive. So 1 plus 11. I'm going to take 5 in the denominator, and then I'm going to have x plus 2, and then plus, we're going to have 6 over 5. We're now going to have x minus 3. So that is how you get to break this into partial fractions.